Hello everyone, welcome to Gate Forum. So let's start this video. In this video, I will be covering hydrostatic and pure shear, means two special cases for Mohr circle. So already in the previous lecture, we have done the Mohr circle for 1D as well as 2D. We have learned how to draw the Mohr circle and center, radius and principal stresses also. So here we have two cases. So here hydrostatic case is the first special case, and pure shear is the second special case. Why these two are very special? Because something special here in terms of result as well as so many questions asked in PYQ. That means in previous year examination, previous year question we have. Okay, so let's start video. So first of all, we are going for the hydrostatic loading, that is case number 1 or special case number 1. So what do we mean by hydrostatic loading? First of all, let me tell you. Hydrostatic means whenever there will be no shear stress. Suppose I am considering like this. Here we have one cube and here we have stresses like this sigma x. Here we have sigma x. Here we have, let's say here we have sigma y, and here we have sigma z. That means in the x direction, y direction and z direction we have normal stresses but no shear stresses. That means tau 0 on any phase. On every phase tau will be 0, like this only. That means if tau 0 and sigma x is equal to sigma y is equal to sigma z is equal to sigma, if all three will be equal, this condition is known as hydrostatic case, first of all, for 3D. But 3D is not in our syllabus. That's why we will move to 2D hydrostatic load. We will move to 2D hydrostatic load. So what is the meaning of 2D? That means only sigma x and sigma y here we have. On one phase here we have only sigma x, and on another phase here we have only sigma y like this only, sigma y like this only, and no tau xy. And sigma x is equal to sigma y and is equal to sigma only. Both are equal, and no tau xy. Tau xy will be 0. Tau xy will be equal to 0. So this is known as 2D hydrostatic loading condition. Sigma x equal to sigma y and tau x equal to 0. Suppose if we go for plotting the Mohr circle for this. So already in the last class I have told you, whenever you have to plot Mohr circle for any type of problem, two things we have to do. First thing, we should go for the writing the coordinates of the two perpendicular planes. So here we have first perpendicular plane here we have, and here we have second perpendicular plane. Suppose plane number A and plane number B, or plane name B here. So what is the coordinate here? We have sigma comma 0 here we have, and here also we have sigma comma 0. If you plot these 2 points acting as a diameter, suppose if some point will be plotted here as A, some point plotted here as B, like this only, A and B plotted here like this only. So AB will be acting as a dia of the circle. AB will be acting as a diameter of circle and center. And here we have radius. Here we have radius and here we have center. So AB will be always, this A and B will be always end points of the diameter. So suppose if we draw the Mohr circle, like this only, sigma versus tau graph, here we have sigma and here we have tau. So where is the first point A? The first point A, here we have sigma comma 0. First point A here sigma comma 0, and second point here we have B, which is sigma comma 0, same point here. So what is the length of the dia? That means here AB at same point, A and B at same point, both will be at the same point only. That means what will happen to the dia of the circle? So you will say, sir, diameter will be 0, sir. Length of diameter will be 0. That means radius will be 0 for this Mohr circle only. So here we have center C. So this is the circle and this is the Mohr circle. So Mohr circle is a point. So here we have a Mohr circle. So you say, sir, this is not a circle. This is a point. Yes, I know this is a point, but I will call it as Mohr circle. That means in case of hydrostatic loading, Mohr circle is a point basically. So if somebody will ask, what is Mohr circle? So how is the Mohr circle? So you will say, in case of hydrostatic, only in this case. Remember, only in this case. That's why this is known as a special case for Mohr circle. So here only for the Mohr circle, we have Mohr circle is a point. But please remember, once again I am telling you, only for this case only. If somebody will say you that Mohr circle will be a point for any other case, you will say no, not possible. Only for this case only. That is for the hydrostatic loading condition only. Okay. Here we have. So now, if here Mohr circle will be a point here, so what will happen to the radius? Radius 0, diameter 0, and what will happen to sigma 1, sigma 2? So here both will be equal. Sigma 1 is equal to sigma 2. Sigma 1 is equal to sigma 2 here we have. sigma 1 is equal to sigma 2. So what I can say in case of hydrostatic loading, here we have sigma 1 is equal to sigma 2, which is equal to only sigma x, which is equal to only sigma y, which is equal to sigma and tau xy, or tau everywhere will be 0. Tau everywhere will be 0 and tau xy 0, tau maximum 0, every tau will be 0. Every tau will be 0. That means I can say in this case, this is the first special case which is hydrostatic loading, and the special case I can say sigma x equal to sigma y is equal to sigma 1 is equal to sigma 2 is equal to sigma. Every sigma will be same first of all, and diameter radius will be 0, and here we have any type of tau, that is any type of shear stress will be 0. So please remember these points. So I'm writing the important note point one once again. Here I am writing for any type of hydrostatic loading. If whenever we have hydrostatic loading in special case, so what I can write, first of all, we can write sigma x is equal to sigma y is equal to sigma 1 is equal to sigma 2 is equal to sigma, first of all sigma will be same first of all. And second thing I can say, any type of tau, all tau will be 0. All tau will be equal to, all tau means, what is the meaning of all tau? Somebody will say, what is the value of tau? Equal to 0. What is the value of tau xy? Which is equal to 0. What is the value of tau yx? Tau yx, which is equal to 0. What is the value of tau max? Which is equal to 0. That means all the values of tau, whatever the value of tau will be 0. No value of tau, no value of tau first of all. Okay, here we have sigma x, sigma y, sigma 1, sigma 2 will be equal, and what will happen to the diameter? Diameter is equal to 0. What will the radius? Radius will be equal to 0. And very interesting, one more important point, number of principal planes. Number of principal planes will be infinite. Number of principal planes will be infinite. Number of principal planes will be infinite, but generally for 2D we have two principal planes, but here this is the different condition. Number of principal plane is not 2 but infinite. For example, suppose if here we have a circle, here we have one principal plane, here we have another principal plane, two principal plane, 1 and 2. Two principal plane here we have, that is 2 pp, two principal plane here we have. Suppose if circle is smaller, even though here we have one principal plane and here we have another principal plane, here also two principal plane here we have. But here in case of hydrostatic only, this is the point only. So all the points of circumference will be at the, all the points of the circumference will be at the x-axis only. That means here we have all planes are principal plane here. All planes are principal planes, or all planes are principal planes. That's why here we have infinite number of principal planes. Infinite number. So please remember this page, very important page here we have. That is for 2D case, if we have hydrostatic loading, then sigma x equal to sigma y is equal to sigma 1, sigma 2, sigma. All type of tau will be 0, dia radius will be 0, and number of principal plane will be infinite. Infinite number of all the planes inside the body will be principal plane. Please remember, very important thing. Please remember, very important topic, very important thing, because so many time questions from this topic asked in the GATE examination, sometime for 2 marks, sometime for 4 marks, like this only. But most of the students used to do the mistake. What mistake they are doing? They are not knowing how many principal planes. That is the infinite number of principal planes. Because all the points on the circumference coming to the x-axis, coming on the x-axis. That's why all the planes inside the body will be principal plane, and we can say number of principal planes will be infinite. Okay, very simple. Now moving towards the next case. So here we have a page for special case 1, but we are moving to the next case, that is pure torsion. Next case, pure torsion. But suppose if you say, sir, where we can have a hydrostatic in the real life? Let me tell you the hydrostatic case in the real life also. Suppose here we have a static liquid. Here we have a static liquid like this only. Liquid at rest here, static liquid here we have. Okay, rest or static liquid here we have. Let's say water here we have. At any particular point, we know according to Pascal's law, pressure will be same in all the direction. Like this here, pressure P here, pressure P here, and here we have pressure P like this only. So what I can say here at particular point A, suppose this is the point A, na? at particular point A, pressure will be same in all the direction like this. Here we have P, here we have P, all the pressure will be here P, here P like this only. So what about sigma x and sigma y? What about sigma x? You can say, sir, sigma x will be here. Here you can say, sir, sigma x is equal to sigma y is equal to minus of P, is equal to minus of P like this only, minus of P like this only. And what about tau xy? What about tau xy? So this will be 0. So obviously it is a hydrostatic condition. Obviously it is a hydrostatic condition. Obviously it is a hydrostatic condition. And according to this condition, where we can have a Mohr circle on the negative side of sigma, not on the positive side of sigma, because here we have positive sigma and this side we have negative sigma. Here we have tau positive and tau negative here we have. So here we have, this is the Mohr circle. This is the Mohr circle at a distance of pressure P. At a distance of pressure P, here we have circle. Here we have circle or Mohr circle. Here we have circle or Mohr circle, which is a point on the x-axis. Which is a point on the x-axis. So what I can say? We can say sigma 1 is equal to sigma 2 is equal to minus P, we can say. And what about tau max? Any type of tau will be 0. Any type of tau will be 0. Whatever the tau max or tau xy or tau, whatever tau will be 0. Or I can say all tau will be 0. All tau will be 0. All tau will be equal to 0. Whatever the value of tau will be 0. Any type of tau will be 0. And what about the value of dia? Whatever the value of dia will be 0. Whatever radius will be also 0 here. And number of discipline also here we have infinite here. So this is the real life example of the hydrostatic loading. Real life example of the hydrostatic loading. At a particular point we have pressure in all the directions same, which is known as Pascal's law. Pascal's law. From there we will get this state of stress and then we can draw the Mohr circle. Then we come to know that this is a hydrostatic loading condition. Hydrostatic loading condition, and all the features are very similar, means 100% like hydrostatic loading. So this is known as hydrostatic loading here. As you can see, Mohr circle will be a point on the axis, sigma axis, on the x-axis or on the sigma axis, but on the negative side. But here we have Mohr circle. On the positive sigma axis, because here I have shown sigma x, sigma y as a positive here. As a positive here we have. Okay. Let's move to the next. That is pure torsion or pure shear. Now move to the next special case, case number 2. Special case number 2, that is pure torsion or pure shear. So what do you mean by pure torsion or pure shear? Just look at here. Simple pure torsion or pure shear means, suppose for 2D, if there is no sigma x and no sigma y, first of all. If there is no sigma x and no sigma y, no sigma, that is no normal stress 0, but only value of we have tau xy. Only value of we have tau xy like this. Only value of we have tau xy. Only tau xy here we have. Tau xy will be something, some value here we have given here. But no sigma x, no sigma y. This is known as pure torsion or pure shear. Pure torsion or pure shear. Suppose if I am interested for drawing the Mohr circle, so here we have plane A, okay, here we have plane A, and here we have plane B like this, and here we have plane B like this. So what is the coordinate of plane A? So 0, comma, minus tau xy, okay, and here we have 0, comma, plus tau xy. 0, comma, plus tau xy like this only. So if I plot these 2 points on sigma versus tau, where we have these 2 point A, 0, comma, minus. So here we have somewhere A here. This is the point A, 0, comma, minus tau xy. Okay, 0, comma, minus tau xy, here we have point A. Where is point B? Point B will be somewhere here. 0, comma, plus tau xy. 0, comma, plus tau xy. So here AB will be acting as a dia. So here at the midpoint will be acting as a center. Origin will be acting as a center, and here we have circle. And here we have circle like this. That means, first of all, center will be always on origin. Center always on origin. First of all, center always on origin. In this way, we can identify pure shear or pure torsion case. First of all, center always on the origin. First of all, okay, and this here radius, here radius, here radius, here radius. All are radius here we have. So what I can say? What I can say, here we have sigma 1, here we have this value as sigma 1, this value as sigma 1, and here this value as sigma 2, this value here we have sigma 2 like this only. So you can say sigma 1 is equal to minus of sigma 2 is equal to radius is equal to tau xy is equal to tau xy is equal to tau max is equal to tau max. All things are equal, but only sigma 2 will be negative. Sigma 2 will be negative only. Sigma 2 will be negative here, and center always on origin, and center always on origin here we have. Center always on origin here we have. Very simple. So this case is known as pure torsion or pure shear. Pure torsion or pure shear, very easy case. Pure torsion or pure shear, very easy case, not a difficult task. But how to identify? How to identify the Mohr circle, which is a pure torsion? Center will be always on the origin. In this way we can identify first of all. And sigma 1 is equal to minus sigma 2. Means magnitude wise both are equal, sigma 1, sigma 2. But sigma 2 is of negative in nature, that is compressive. Sigma 1 will be positive, that is tensile. So sigma 1 is equal to minus of sigma 2, that means both are equal and opposite in sign, equal in magnitude, opposite in sign, and both will be equal to the radius. Both magnitude will be equal to radius, and which is equal to tau x yx, and which is equal to tau max. Everything will be equal. Everything will be equal here we can have. A number of principal plane, definitely we have only two. Here we have one principal plane, major and minor. Here we have one principal plane, that is a minor principal plane, and here we have one principal plane, that is major principal plane. Here we have major principal plane here we have. So this is a basic list. Please remember only one page. For solving any problem of the GATE examination, please remember only one page. You can solve any problem from this special case, that is the pure shear or pure torsion, from the topic Mohr circle. Very easy, very easy. Now, but sometime what happened? Sometime what happened? You have seen that pure shear or pure torsion will be something else in the examination. Let me discuss that also. Right. Second type. Let me write second type of pure shear. Second type of pure shear or pure torsion. Pure shear or pure torsion. So how to identify, first of all, how to identify pure shear? Already in the last page I have told you, whenever center on origin, that is pure shear, first of all. Now in here, suppose just look at here. Suppose here we have one state of stress like this, that here we have sigma. Just remember, here we have sigma like this. Here we have sigma, but here we have sigma like this. Here we have sigma. That means what you can say? So you can say, sir, sigma x is equal to minus sigma y is equal to sigma x equal to minus sigma y. First of all, sigma x is equal to minus sigma y. If you are writing like this, means both are equal. Here we have sigma x is equal to sigma and sigma y is equal to minus sigma. That means magnitude wise both are equal but opposite, and no tau xy, and no tau xy. Tau xy will be equal to 0. Tau xy will be equal to 0. This is known as pure shear, first of all. If you draw the Mohr circle, how we can go for drawing the Mohr circle on sigma versus tau graph? It is very simple. You will say, sir, every time you are going to take only two planes only. Every time you are going to take two planes to draw the Mohr circle. Here we have first plane, name is A, and here we have second plane, mutual permanent plane, name is B here. Please write the coordinate of these two planes. Write the coordinate of these two planes here. So I am writing the coordinate of these two planes. So here, if for A, it is sigma comma 0. Here it is sigma comma 0. And for the B, here it is minus sigma comma 0. Minus sigma comma 0. Suppose if I plot A, sigma comma 0. So somewhere here we have point A, which is sigma comma 0. Which is sigma comma 0. Point B, somewhere here we have, which is minus sigma comma 0. Minus sigma comma 0. AB will be acting as a diameter of the circle. So midpoint will be acting as a center. Midpoint will be acting as a center, and this will be radius. This will radius, and midpoint will be acting as a center. So center will be at origin. Center will be at origin, and here we have Mohr circle, and here we have Mohr circle. So whenever center at origin, that means pure shear. That means by looking at this, I can directly say it is a pure shear Mohr circle. It is a pure shear Mohr circle. Why pure shear Mohr circle? Because center of circle will be at origin. Center of circle will be at origin. So here also, what about sigma 1? So we will write sigma 1 is equal to minus sigma 2 is equal to minus sigma 2 is equal to sigma x is equal to minus sigma y is equal to minus sigma y, all will be equal, and is equal to tau max is equal to tau max. All the things will be equal. All the things will be equal. So this is the special case. So here we have second type of pure shear. Please remember this case also. But because most of the students do not remember this case. They used to forget this case. They used to remember the first type of pure shear only. But this is also a case of pure shear. Please remember, very simple. Very simple. So here we have done these two type of Mohr circle. That means for hydrostatic case and for pure torsion. So what's the difference? What's the difference? That means for hydrostatic case, suppose if here we have, suppose how we will identify in the examination that hydrostatic case of pure shear. So whenever on the x-axis there will be a point Mohr circle. If this will be a Mohr circle, you will say here it is hydrostatic condition. Hydrostatic condition, because Mohr circle will be a point on the x-axis, but whenever center will be at the origin, whenever center of circle will be at the origin, and all these are radius, then this is known as pure shear. This one is known as pure shear. So in this way, we can identify which one is pure shear and which one is hydrostatic loading. Let me show you all the pages once again from the first page. Let me show you all the cases here we have. Okay. Here we have first page that is for hydrostatic sigma x equal to sigma y first of all, and no tau xy here we have. So this is a hydrostatic case, and here Mohr circle will be on the x-axis only, which is a point, dia 0, radius 0, and everything will be here same. Everything will be, number of pressure plane will be infinite. And here I can say sigma x, sigma y, everything will be equal here we have. And here it can be negative also, hydrostatic loading on positive x-axis, negative x-axis also. So here you can say for static liquid, here I can say that Mohr circle will be a point on the left side of the x-axis, okay. And here we have pure shear case, whenever center of circle will be at origin. This is known as pure shear only. This is the way we can identify the pure shear only. Sigma 1 equal to minus sigma 2 equal to radius equal to tau xy equal to tau max. Everything will be same. Here. And this is the second type of pure shear. Whenever you have sigma x equal to 1 is sigma y and tau xy equal to 0. This is also pure shear. So please remember all these cases. And please remember how to identify pure shear hydrostatic. Only one way to identify. Whenever a Mohr circle is a point, then it is hydrostatic. And whenever Mohr circle is a circle such that the center is at origin, means pure shear. Very simple. And remember, everything will be same. Everything will be equal. Sigma 1, sigma 2, radius, tau max. Everything will be equal. Okay. So we have done this. Okay. We have done this lecture, and we have discussed this Mohr circle. And here I am ending the Mohr circle. We have some strains also left, but this is not a full course. You are watching this video on GATEFORUM YouTube channel, and this is not a full course. This is a course. In this video series, I will be providing you so many lectures so that you can, so that this video can help you out to prepare by yourself. But for full course, you can join GATEFORUM, and you can go for 30 hours class, 40-hour class, 50-hour class, 60 hours class in the full course for detailed lectures, for detailed courses. Okay, so like this video, share this video with your friends, and subscribe this YouTube channel, and watch the whole series. Of strength of metal, whether you are from mechanical engineering or whether from civil engineering. Share with your friends also, like video and subscribe this video. If you have any query, question, any doubt, definitely in the comment box. Go to the comment box, write your query. I will personally reply you on this comment box. Okay, so bye all of you. We will meet in the next lecture, and in the next lecture I will start shear force diagram and bending moment diagram. Okay, in the next lecture I will be starting shear force diagram and bending moment diagram. So we will meet in the next lecture. Okay, bye all of you. Bye.